Hello. In this video, I will show you the basics about the SOLIDWORKS pipe routing add-on. To begin, make sure the routing toolbar is turned on. Select piping. Be sure to create an assembly file and save it. This will make creating your piping system easier. In order to save time, I've already placed a base, tanks, and pump via drag-drop method from the routing pipe library. This method of placement is the same as creating an assembly in SOLIDWORKS that we have already covered in this course. The design library is where you will go to select features for your system requirements. For example, T's, crosses, and flanges, and so on. To route a pipe, you have two options. One, you can manually draw your pipe route in 3D, or two, auto route your pipe.
Let's begin with the auto route method. First, we will have to select a flange. I am selecting a slip-on weld flange. You will now drag it and place it to whatever flange you wish your piping to start. Notice how it automatically snaps to flanges on your equipment. Here you will then click on the type of flange. You will need to know something about piping. Be sure to select the correct flange, which in this case it's a 150. Click OK. Now on the left side, you will see Route Properties, where you are creating assembly. This sub-assembly here on the left is where you can give it a particular name. We're going to leave it as piping 001. You can also modify route specifications, which we will not do. Then under pipe, it has automatically selected 2-inch pipe based on the size of flange. We can now select the schedule of pipe. We're going to leave it as 40. In the bends and elbows, you can select the radius, the bend radius for it, and if it's on the inside or center line. Everything else, options, is just where it's selecting the pipe from, which is in your library. And go ahead and click the check mark box. Save all. And now we are going to select another flange where we wish our pipe segment to end. Now if you notice, on both flanges, we have a pipe segment sticking out. This is where we will begin and end our piping. Also notice, we still have the flange on our clicker, so we can place another flange if we wish to have our pipe connect in multiple places. Now I have 4 segments here, and we're going to auto route one and manually draw the other. To auto route, up in the toolbar, select auto route. Now click both nodes by holding shift key of where you want your pipe to run. As you can tell, the pipe goes through our tank. So over in the left column, under auto route, you can modify to alternative paths by clicking the up or down arrow. Here we finally have a pipe segment that does not interfere with any other pipe or equipment. So let's click the checkmark box. Now we can install a T. And all we have to do is go to our library, select T's, select a particular T we wish to use, and drag it to the pipe segment we want it in. Once you get here, you can hit Tab to rotate the direction of the T. Here you will also be prompted to select the appropriate T for this pipe. Now you see there is this pipe segment on the end of the T. From here we can manually draw a pipe segment. Now we are sketching in 3D. Now be sure to verify it's going in the correct direction. So to change the axes, you just select tab, and you can see your axes will change as needed. At this point, we can either add in flanges, tees, or reducers as necessary to complete our piping system or our skid system. At this point, we're going to just confirm our sketch and allow it to model. Now we will conduct flow analysis on this pipe segment here.
Now we'll be showing you guys how to do a flow analysis, flow simulation. So if we don't see this around here, now we can go to the SolidWorks add-ins and we can add our flow simulation. Once we do add it, then we have to start a whole new study. We can give a desired project name, whatever we want to. So for this one, we are just using our Flow Analysis Lab 11. Now we'll be choosing our units for the system, and we can change whatever we want. Like we can use PSI, we can use SI systems, we can change our units of temperature, pressure, mass, whatever we do need. We are using an Kelvin, and we are using our SI units for our simulation. Then we can choose our flows here. We can work on internal flows or external. We are doing internal. To do the internal flow, we are using heat conduct and solid, and which is going to be dependent on time and gravity. Our gravity is in a Z component, so instead of using Y, we are using in Z. Now we click next. We can choose our liquid, and we'll be choosing water. These all are predefined values. We can choose water, R134, a propane, methanol, ethanol, anything that we do want to. And now we hit add. And we'll choose our material type as well from here. We are choosing a mild steel. Our material will be depend on heat transfer coefficient. Since we are doing a flow analysis, it doesn't matter how our material is going to conduct with our water. We are giving a really small values of heat transfer coefficient, but you can change it at your conditions. And we are giving a little high temperature than our room temperature. Now we'll be providing our thermodynamics parameters, and which is a pressure, like we'll be providing a pressure and temperature and a solid parameter as well. And we'll be changing our initial solid temperature to our earlier temperature, and then we'll be hitting finish. Now we'll be changing transparency of the material. Just we do need to select the inside portion of our pipes. So by hitting on your flow simulation profile, we can change our transparency, and we can set the values where do we want. And I have chosen it at 0.5, and then we can set our material type by inserting a material, and we'll be choosing the body of our pipe, like the whole pipe, and it will be showing us a predefined materials, and we'll be choosing the same material that we have chosen earlier, which is mild steel. Okay, I'm hitting cancel just because I have already done my simulation. Later then will be to do the flow analysis, we do need to close the pipe, so we are adding 2 of the lids at the end, and those lids should be made up of insulator. And to add those, we can go to insert the body, and we can choose our lids from both ends, and then we can give a predefined value of insulation by going in glass and minerals and using an insulator. Now we'll be giving the boundary conditions to our pipe, and to do that we'll be selecting an insert boundary condition. First of all, we are using the inlet side, the inlet portion of our pipe, and which is going to be the inside body of our lids. By selecting the right parameter, we can give the inlet conditions, and we have to give a mass flow rate as well. We are giving a random value just to do the simulation, and we'll be using a thermodynamic parameter like our temperature that we do give earlier. And then by saving this, it is going to be our inlet condition, and then we do have to give a outlet condition as well. By repeating it same, we be choosing the outside portion of our pipe. At the outlet conditions, we are giving our static pressure instead of giving an inlet mass flow rate. So we'll be choosing our static pressure and giving the desired values. We can set our outlet conditions, and then before we hit the run, we need to give a time, like at what time we do want to calculate our flows. So by using calculation control options from input data, we can set our time and then just hit run. It will take a little time to do it, but once you done your analysis, it will ask you to load your files. Then by loading it up from here, you can load your results. Once you've done it, then you can look what like the temperature variation and the pressure variation on your pipe. By going and edit definition, we can choose our both of the ends of pipe, and then we can select what do we want to see. Either we want to see our pressure or temperature variation through the pipe, and we'll be looking these conditions at max. So instead of plotting some boundary conditions, we are plotting it at the maximum conditions, and by hitting OK, we can see our results. And here are the results from our analysis, and I'm going to zoom in to show you guys how it's look like. So yeah, you can see a little bit of turbulence here and some backflows in there, if you see right here. From here, we can modify our pipe geometry as needed to reduce turbulence.